Welcome to the desk of Ladyada, where we figure out if you replace all the planks in a ship, is it the same ship? Hi, Ladyada.
Long story, but we can explain that later. It's a late night here at the desk. We're actually wrapping up for the night. Thought we'd do a little stream before we lay down and pass out. And today I was working a little bit. Actually, I mostly chilled out this week, but today. But I worked on some more bonnets.
That's the title of the show.
That's the title of the show because we are getting to more. I actually had one big run where I think I did 7 or 8 bonnet designs, and I'm just finally getting to the last 1 or 2. We did the Charlie Plex bonnet last week, and we also did the Joy bonnet, which I actually got some cool silkscreen to show. Let's go to the computer. Were you at the computer? Yeah. So the Joy bonnet was. Hold on. Let me see if I can put it from down here. It was this kind of game stick bonnet with a joystick and some buttons.
I showed on the overhead.
Oh yeah, sure. So this is it. So it's got a thumbstick.
Yeah.
And then select, start, 1, 2, up, down, left, right. We went to an arcade today, so that's kind of nice. That was fun.
We went to Barcade on St. Mark's.
But then you can also make your own Raspberry Pi Zero based arcade game. So this works really well. It turns out that the reason I was having problems with the NES emulator last time was it doesn't actually work in RetroPie 3.8. So when I upgraded to RetroPie 4.2, it all worked. Everything works great. And I overclocked the Pi Zero a little bit, 200 megahertz extra. And it does NES and MAME emulation perfectly, so that's great. And it also does audio out on the HDMI. Okay, so then can you go back to the computer? So then I tasked Phil B with designing, this is the design for the silkscreen, which is good, but it would be nice to have a prettier silkscreen. So I tasked Phil B with, hey, could you come up with something? And he's like, well, the bottom could have some really cute text, maybe some very Nintendo or MAME quotes, and then the top maybe something like this. I'll shrink this down. So something like this, where there's a sort of a Nintendo SNES-y sort of overlay, and then maybe it would be a white PCB with black silkscreen for the best look. So we're still thinking that I'll chat with him more later and see what he's come up with. So that's that. The Joy bonnet works. It's just silkscreen is something I don't do another revision for. I just run them as is. And then okay, so can you do the overhead? So there's 2 more bonnets from that run. There is the radio bonnet. It's a LoRa or RFM 69 bonnet that just does SPI communication to these RFM or LoRa modules. So we'll get that. We have to work out a whole gateway and figure out how to make sure that works. And then the second to last one is this OLED bonnet, and it has a 1.3 inch 128 by 64 OLED, 2 buttons, and a sort of a 4-way selector switch. So I thought let's get that working. So how about we try that out? I think that just reset my Pi, but that's okay. So let's go to the computer. Yeah, that totally reset my Pi. So let me see if I can get it back. Hard reset. Yeah. There's your watch out. You have to put it in correctly, otherwise you could short power and ground by accident, which is always kind of sad. And let's try now. Okay. So luckily, I didn't have to write pretty much any code because we already have a full guide on how to get these OLEDs working with Raspberry Pi. We already wrote the code like 2 years ago because, you know, we have these breakouts that people like to use. So, you know, all I have to do is basically adjust the code as necessary, but it pretty much will just work. So that's what I did. And you just have to install the GPIO Python code that does the interfacing between like SMBus and the Python. We just have a little wrapper to make it a little easier and nicer. And then in the Adafruit Python SSD is the chipset. It's a Solomon Systech. They do almost all OLED driver chips. So like the size and shape of the OLED may change, but the OLED itself is almost always an SSD chipset design. And then you install it with, you know, the setup and you know, sudo python setup install. And then we have a couple of examples. So the first example is just called shapes. Oh, and then, so if you go to the overhead, it actually isn't, it's like all finicky. And the reason it's all snowy is because I actually have one chip that I didn't have here, so I was putting this together and I realized I forgot to order it. This little reset chip isn't in place, so you need to manually reset it. So, and then run the code again. When you have a lot of these OLEDs and displays, I noticed that you can't just pull reset high. They actually want to have like a proper reset pulse. So instead of wasting a GPIO pin on that, I usually have a separate chip. Like this is an APX 803. It's a little chip that what it does is when, as it sees the voltage rise, it pulses the reset pin low for you. It does an automatic reset. It saves you a pin because you rarely need to reset after it boots. Anyway, so you can see there's some shapes. And with Arduino, we have like a graphics library. The way we do it with Python is to make it easier on us. We don't, oh, can you go to the computer? We don't like write all of the functions for like draw square, draw rectangle, draw circle. Instead, we use the Python imaging library. And like, you wouldn't do this on MicroPython or CircuitPython. But if you have a full Linux computer and you have tons of space, the Python imaging library is like, you know, a couple megabytes, but it doesn't matter. And it does take a little bit of time. You have to like do a whole buffer and you write the buffer at once. But it's really nice because it like does all the font management for you, and you can like load JPEGs and like do animated GIFs. It makes everything so much easier when you just use the imaging library. It kind of handles all that for you. And all you do is basically give it it has a frame buffer. You basically allocate an array for your display, and you use Python imaging library to draw into that buffer so you get all the drawings you want, and then you blit it. You write that buffer into the display at once. So like for example here you can see, it's been a while since I did Python image library, but basically you create an image in Python image library. It's 1 bit, which is 1 bit depth, it's monochrome, and the width and the height, of the display, so 120 by 64, and then you draw into this image. It's like you get a frame buffer. When you draw, you're not drawing to the OLED. You're drawing to this chunk of memory, and you can draw some shapes and again ellipses and rectangles and polygons, everything. And then fonts, you can load true type fonts of any size and italicize them. And then you display the image. You write the image to the display. So the only thing you have to watch out for is when you do this, when you use Python Imaging Library, is because you're writing the entire display every time, you just have to, first off, you have to remember to write the display. It's not like when you draw on a screen where you're draw a rectangle and the rectangle appears. You actually have to kind of tell it send it out. And secondly, if you want to do animations, you're going to be sending out the full screen every time. Now, you could do windowing and only write certain sections, but honestly for a 120 by 64 pixel display, it's not worth it. Just you write the whole thing. What's up?
Is the new Arduino graphics library much improved over UC glib?
They're all kind of the same. You're not going to find much difference. The reason Arduino graphics libraries aren't that great is not because the graphics libraries aren't that great. The graphics libraries are very lightweight. Just 8 megahertz just isn't very fast. And with a Raspberry Pi, the graphics drawing stuff is not what's slowing things down. It's definitely going to be the I2C
Okay.
stuff. So then another example we have is image. So this is a example where it draws an image. So you go to the overhead, and it's this adorable cat friend.
Yeah.
Hold on. I know it's not.
We'll show MOSFET at the end because he's up here.
So
have
it's
a
nice,
cat.
again, it's really easy to draw images with the Python library. And then the final example we have is animate. So let me do that. So animate is a little code that takes text and manually animates it. And so this is a really good example for when you want to see how long does it take to blit out the display. You can do the math, but nothing beats actually checking it. So let's go to the oscilloscope.
Yeah,
Maybe.
I will.
Okay. Meanwhile, I'll hook up my probe here. And I'm going to probe the I2C clock line. So,
Oh, is this Python 2 or 3?
oh, it doesn't matter. They both work.
Cool.
Okay, so that's the I2C data. A little tough to see, but let's do a single sequence, and you can see it takes. That's you can kind of tell there's a little bit of a gap there. So that's that chunk here is 1 blit. So that takes 110 milliseconds for about, right here it says 8.9, about 9 hertz, which is okay, but it's not great. The good news is it's really easy to fix. So, a second. When you zoom in, whoa, too much zoom. Measure. The frequency is about 100 kilohertz. So that's the default frequency for I2C. Almost every device works at 100 kilohertz, but it's not very fast. Some devices can go up to 1 megahertz at I2C, which is pretty amazing considering it's a pull-up based protocol. But when you look up the datasheet for the SSD 1306, which I probably
While you're doing that,
still have
do we ever have plans to stock a round OLED?
there aren't any really good ones.
If y'all know some good ones, email support@adafruit.com, attention Phil, and we'll check it out.
Yeah, I have a couple samples, but none of them are super great. So let's go to the data sheet real quickly. And if you search for timing, you'll actually want to look at the I2C timing interface. And then you get here and it'll tell you basically what you're looking for is what is the clock rate you can do. And so the clock cycle time to give you in microseconds, which is great. We'll just convert that, so 2.5 microseconds. 400 kilohertz, which is pretty common. 400 kilohertz is kind of like, it's either 100 kilohertz for like really slow stuff, 400 kilohertz for like most things, and then 1 megahertz for like stuff that's like specifically designed to be high speed. So what we have to do is just like speed up the I2C interface on the Pi, which is not too hard. I thought maybe you could do it through like the SM bus interface, but turns out it's kind of hardware. It's not like Arduino where you can like dynamically change it by changing the clock. Let's quick chat. What you do is edit the boot config, and it's at the bottom here. It's I mean, you could model load it, whatever, but this is fine too. DT param, I2C baud rate, and then you set it to the baud rate you want. You can literally set it to any number, I think, and it will do the best it can. Let's go with 400 kilohertz. I'm sure you could overclock it probably to 500 or 600. Let's start with this, and then you have to reboot. So reboot. We unplugged this, yeah? Oh, yeah. That's why it's not coming up.
Okay, while you're doing that.
Yeah, is there any other questions?
No, I'm just gonna point
Yeah.
out that. No, I'm just gonna point out that. No, I'm just gonna point out that. No, I'm just gonna point out
Okay, so I'm logged back in. Let's go back to the OLED code. And then let's run animate again. So this time, let's go to the overhead. It's much faster. It's about like 4 times faster because we went from 100 to 400 kilohertz. And let's go to the oscilloscope. And, whoops, I think okay.
But Ladyada, how can I be that girl?
I think I shorted STL to ground for a second. Okay, so now the frequency is a nice and perky 400 kilohertz. And then let's zoom in all the way. Zoom out all the way to see how long it takes to do one. What's nice is like, you know, it's locking nicely, so you can see like this is definitely. It's blending out the data, and then over here it's, you know, computing what the image is or something. So cursor, let's set this cursor over here. So now instead of 110 milliseconds, it's now 35 milliseconds, so about 4 times improvement. And then instead of 9 hertz, it's about 30 hertz. So, you know, 30 hertz is about as good as you're going to get. Any better, it doesn't make much sense. I don't think, I mean, our eyes are pretty happy with 30 hertz, and so I'm satisfied. I think that, you know, I2C isn't very fast. I was thinking of, well, maybe you should make this bonnet SPI, but, you know, it's like a waste of the pins in case you want to use it for something else. I2C is just like so convenient and nice. You don't have to worry about like if the pins are being used, as long as the address isn't, and especially when the reset pin is taken care of for you. So I think this is good. I'm satisfied with that. I'm glad I actually got to try that out.
Okay.
So the next question I have, and this is for Phil. So let's go to the overhead. So I designed this with 2 buttons here. So there's like 2 buttons over here. 'Cause that's space. Like the OLED is this big, so I had some space. So I was like, well, let's add some buttons over here, and then let's add this like this joystick-like thing over here. And you can select 2, and it's just connected to GPIO, and I could write some code pretty easily just to read it and display it on the OLED. I'm not worried about that. That's like the least of my problems. But the problem I have is, so I'm gonna remove this because we're pretty much done with this code. cancel. Actually, let me, I'll do a proper shutdown. Okay, great. So, the problem I have here is, you know, this switch is like really tall. So like you can see, the buttons are pretty short, the OLED is pretty slim, but this joystick is like insane. So my question to you is, I've got a couple other samples. So I've got this,
Yeah.
and this is the switch that we're using. This is an SMT directional joystick. It's kind of a standard SMT joystick. But yeah, it's like super tall. And then I've also got this joystick, which is kind of the same pinout, but it has like it's not even taller, but it has a kind of a nicer profile.
The suggestion is to put a spacer underneath the OLED.
Why?
Maybe post up Y,
Yeah.
Aaron.
So this joystick has kind of a nicer feel. It's like softer. It's a grounder, so it doesn't kind of bite into your finger as much. But it has the same footprint. And then I also have this like ultra tiny joystick, which is like way slimmer and shorter. It's actually kind of like a petite version of this one. So my question to you, Phil, is what do you think I should use for this design?
I like the longer one.
This longer one?
Yeah.
Or this longer one?
The one to your farthest left.
This one?
Yeah. Oh, level out the OLED with the joystick is a
Oh
suggestion.
no, like you're not going to be able to do that.
Can't do
It's
that.
like
Okay.
the cable for the OLED's not long enough.
Yeah. Can I see the different ones?
Yeah, here. These are the three different options.
Come on, focus. Focus, Phil. Focus, Phil. A little blurry tonight.
Yeah, whatever.
Am I? Oh no. Couldn't tell if
It's
I
a
was
late-
blurry or if it was.
It's a late night.
Oh.
Blurry's in.
I like this one.
Which one? Even though it's gonna stick up this one. You actually like the original one?
Yeah.
Why?
Feels best.
You don't think it's too tall? It's crazy tall.
Yeah. I mean,
I was kind of going for
this one.
this-
This one works. This one works.
Yeah.
And it's not too much different.
I mean, do you think like it matters that it's just like it's just so tall? It's kind of tall. I mean, maybe it doesn't really matter. It's also like chunky. Maybe that's the thing.
I kind of feel like if you're going to be playing this thing, you want to give the person the most surface area to play the game or whatever they're
No,
doing.
but it's not for playing games. It's for interfaces.
I know, but still.
It's for like, oh, I want to change like the radio station. Like, there's nobody's gonna play games on.
Yeah,
Well, I
but-
mean, like Snake. Like, not really.
But the people who buy these have kind of big fingers. So you need something bigger. So
So this small one you're saying is too small.
that's too small for sure. So it's between those two.
Yeah. I like the slightly slimmer one. I mean, I know it doesn't matter too much, but I just think it has, like, it also kind of matches the buttons a little bit better.
Can I see? Can I see with the buttons?
Because I'm going to do a redesign anyways, like my last
Yeah, I see what you're saying.
prototype design.
Well, what can you put on top of this?
Well, I could probably ask them if they have some sort of button or knob or
Yeah,
something.
why don't we
but they
find-
may or may not have one.
Yeah, I mean, like, it looks like you can 3D print anything,
Yeah.
and you can put anything on it. Yeah, either one of these is fine. I mean, I'm partial to the one that's on there.
Really?
Yeah,
You like them more? Well, so we have it in stock, so it's like,
yeah.
okay. Well, you know, I can make it so that we can use this one to start, the bigger one, and then, I mean, it actually is the same footprint, so it's kind of a nice thing. So
Yeah.
like this one has, like this footprint, it's the same footprint for this one.
Yeah.
So you can, well, it's reversed, but like,
Yeah.
you can use either one, so we can change it later. I just have to put little holes in the bottom.
The suggestion is an analog slider pad.
Won't fit.
Won't fit.
So yeah. This is what we got. That's cool. Yeah, maybe I mean, like, if it's one of these two, I'll just make it so you can use either. And then, we can always just decide later which one. Like, I have a bunch of these already in stock, so, like, that, you know, that does make it a little easier. But these are functionally the same. Just, like, slightly different. Okay, well, that's all I got.
Okay, that's just Ladyada tonight.
Yeah.
I got some stuff going on.
What do you guys on?
The code is removed. I put it in the chat. 10% off in the Adafruit store all the way up to when I wake up,
Sounds good.
which is like 4 hours.
No, we're gonna sleep in a little bit.
Yeah, so use the code, get some stuff. Oh, compatible touchscreen and on-screen D-pad.
There's no such thing.
Lots of requests. If you know of one.
I love all these requests for things that don't exist. These things don't exist. There's no capacitive touch that's for that.
Yeah. Can you go to the overhead?
Yeah.
Okay, so I have a few things I was going to show.
Okay. Oh, you want me to?
Yeah, you show them. Get the Minty Boost there.
Okay.
So check this out, folks. This is the first, or one of the first Adafruit kits. This is from over 10 years ago. And I bought this before I met MOAR.
Yeah.
This is the first logo, and I remember when you met me,
It's a
you said,
kiwi.
yeah, it's a kiwi. I remember when you met me, you said, can you make me another logo? So that's where the little star logo came from.
Yeah.
Yeah.
I like kiwi things.
Yeah, and then the other thing is we're working on some little packs with Phil B. This is like a little resistor pack. We've got those in the mail finally.
Yay.
Yeah. Also, this is a book. You should just buy tons of copies and just give them out to everybody. Managing Oneself. And then I got a little treat.
It's short, but effective.
Yeah. No, seriously, if you manage employees.
If you manage people.
Yeah.
Or manage yourself.
Or if you're being managed.
Or you're
Can you
being
put this under the overhead? So
Yeah, this is
I got this Nikon 4K camera because we're doing this thing with Google where Ladyada is going to talk about Adafruit, and they said they like 360 videos. So I'm trying this out, and let me tell you what I found out. It records fine in 4K, and it's nice and standalone, but you can't do live 360. Some cameras you can, because eventually you'll be able to do live 360. I can do it with my Theta, and I think another one, but this one, it only does HDMI playback. It doesn't do HDMI live. So anyways, as I explore different equipment, I'll let y'all know, but it's a neat little camera. It just doesn't do as a source.
Yeah.
So if you
No.
plug it in HDMI,
Like right now, you're using an HDMI. This camera is an HDMI
yeah,
camera that has. You're using it as basically a very nice webcam.
yeah. You know, I'm not quite sure why the
I don't know why it's flipping out either.
yeah,
They just started doing it recently.
yeah. I think it's the actual cable, believe it or not.
We got tons of cables. Do you want to swap it out next time?
No, yeah, sure, but
These
I think.
flat. This is a. You know what? This is a sample cable,
Oh yeah.
and it's insanely long. It's a 20-foot cable.
I think that's what's going on.
So we gotta get rid of this cable. All right. Well.
So you
But for now,
can't.
it's Max Henry.
So is it possible to make a capacitive touch screen the right size?
No.
Okay, there you go. It's that simple, folks.
It's that simple. If
Yeah.
they're not manufactured already, you're not gonna get them.
Okay.
You have to find something that's already used in a phone or a product that's that size, and there's nothing that uses that screen size. So
All
there
right.
are no capacitive touch screens for it.
And that's it for the Desk of Ladyada tonight. Thank you, everyone. If you want to support an open source hardware company, purchase some electronics because this is the only thing that keeps us going.
And it's late,
Yeah.
and we have to pick components out.
Yeah. All right, that's it, Ladyada.
All right, sweet. We'll be doing more broadcasting soon.
Of course.
Stay tuned.
Yep. Ha! Y'all thought we forgot the cat. Here, you can hand him to me. Yeah, I know.
He's very tired. He doesn't understand.
This is, yeah, y'all started to tune out, but look, we have a live cat. He watched Earth 2 tonight, and there were snow leopards.
He liked it.
Yeah.
He is not a snow leopard.
Nope.
He's a bed leopard.
Yeah. All right.
Okay. Cat is alive.
You stuck around.
We've proved it.